running somewhat late today. Oh shit. Okay. Well, running late or not, get to it. It's a cellular automata. I'm not gonna place on this tonight, but I'll go fast anyway. Table.insert row, comma, C is dot and floor or empty. Yeah, empty. For y, comma, row in I pairs of seats for x minus 1. Cellular automata. Unable to connect to chat. Please try again later. Well, I'll try again later if I have a little bit more mental bandwidth. So if you're in the live stream, hello, I'm sorry. If adjacent of y comma x is 0, local US equals S. And S is empty. adjacent seats is greater than or equal to 4 and S is occupied, then the seat is now empty. If the new seat is not the seat then changed, table dot insert row new seat, table dot insert S new row new local occup equals 0. If new S is occup, then tote occup equals tote occup plus 1. Cool. Change 0, then break end. Lua 11.lua arrow 11.input. Figure out what I fucked up. There's one of them. Oh no! Yee-hoo! Print yx. Okay, that's not gonna fly. That's not gonna fly. Okay. Yeah, that's not too bad. All right. That's not too bad for starting late. Boy, I had a heart attack for a moment there. Okay, so change the adjacency function. And function look yx dy dx. Max x equals 0, max y equals 0. If max y is num seats, max x equals num seats sub 1, while seats sub y and seats sub y sub x do end. And seats sub y sub x is not, or is floor. Y is y plus dy, x equals x plus dx. Print, no printing bullshit right now. Come on. Return seats sub y and seats sub y sub x and seats sub y sub x is occupied and 1 or 0. Look yx minus 1 minus 1. I hope this works. I'm just winging this here. I'm not I'm just going to try not to think too hard about this. 2, 3, 4, 5, 6. 7, 8. I wonder if I would have stood a fighting chance if I had not had an appointment. Well, there's been a pop. I've had email. I'll look at the email later. Okay. I think I've adjusted the adjacency function. Jesus. That's not good. Uh-oh. Takes 5 or more. Did I update that? Yes. Ooh, geez. That's a big one. Let's cat r11x.input. Print look. Da-da-da. Oh, shit. Go faster. Hey, that's really not half bad for having started late. I think I must have started like 2 minutes down or something. Maybe even 3 minutes down. And I don't know. What did we? How did we do? Okay, so let me go refresh and see if anybody said anything over here because unable to connect to chat. Leaderboard capped out at 1406, and I did it in 1633. So, okay, if I was down by 2 minutes, then I wouldn't have gotten on. But if I was down by 2.5 minutes, I would have gotten on the leaderboard. Hey, I feel pretty okay about that. Cool beans, jelly beans. Yeah, cool beans, jelly beans. Let's see. Git add 11.lua, 11b.lua. Git commit -m 11. Cellular automaton problems. Fun. I don't know. I like cellular automata problems. And that one had a nice twist on it. Nothing super special. I think this is the longest code that I've had to write so far this year. Word count. Star.lua. Yeah, it's a 71 liner. It's the most code that I've had to write so far. Yeah, you know, this is, I don't know. I think this was a more fun problem than previous nights. I don't know. Maybe you did, maybe you didn't. A lot of people had trouble. I don't know. Is it still the case? As long as I'm commentating. It's still the case that a lot of people, wow, a lot of people still had trouble on part 2 of last night's. So the trick, I don't know if you're just watching this and you don't know, if you're a newer programmer, then hi, welcome to the channel, I guess, the channel. So 10b.lua. Let's just talk for a moment about, there's an obvious way to write last night's puzzle, to implement last night's puzzle. And the obvious way is that you go looking recursively through. And so you start at 0. Okay, I'll start at 0. That's my base case 0. And then for 0, you want to go figure out how many adapters are, can be connected to it. So n+1, n+2, n+3. Okay. And so you keep iterating through it like that, and then you go all the way to the end. But the problem is, lua 10b.lua arrow 10.input, is that number is really big. And if you go through the loop every single time for each and every one that you hit, that's like big O of n factorial time. That means it's proportional to the factorial of the number of input combinations. I think that's the case. I don't know if it's actually O of n factorial or just some other massive polynomial. I think it's n factorial though. Anyway, all that is to say is on any reasonable system, even if you have a very, very fast runtime, you're just not, that's just a number of iterations that you're not going to be able to hit. So how can you avoid that? And the answer is that a bunch of those times you're doing repeated work. And so if you think about this, let's just think about if you start from number 16, right, then you can remember that there's only one path from 16 up to 22, and this is the example here, right? There's only one path from 16, 19, 22. And so rather than recurring on 16 and then 19 and then 22 and then back out to 19, then back out to 16 and then back up from there, each and every time you ask about number 16, you can remember that you already evaluated for 16, because that's not going to change, right? It's not going to change each time you come through. And so you can remember that. And that trick is called memoization, and not memorization, but for some reason they took the R out, and it's called memoization. So anyway, it's a very, very simple thing, and in Python, you can use a decorator like @cache or something like that. In Lua, we don't have that, so we have to implement it by hand. But that's educationally useful anyway, because it means that we can show how it works. It means that at the very beginning, when we evaluate this, I check to see whether I've already, so I have this function called nways, and I have a table called nways memoization. And so I check to see if I've already evaluated this function nways on this particular input of jolts, and if so, then I return that value that I've come up with before. And the other trick is right before, and this is what bit me in the ass last night and caused this to run for like 10 seconds before I figured out what was going on, was that every time you evaluate the function, every time you actually do the hard work of evaluating the function, then you write down the answer at the very end. So I write down, just before I return ways, I write into this nways submem table the ways for that input jolts. So that's the trick for last night. For the 10,000 of you or some that are stuck on last night's part B still, that's the trick that I really, and this this is just one of those things that's super handy to have in your tool chest. It was I think if you watched me do this in real time last night, I identified it right away. I was like, oh, right, this is just going to be a memoization problem to make this not... And you get an intuition for this eventually. You get an intuition that you're going to go, oh, this is going to take n factorial loops through. So, and I think Eric even gave us the hint. Surely there must be an efficient way to count the arrangements. When he says efficient, he means don't do the simple thing. He means do something that's a little bit more reasonable in some way. And so this, I believe, takes it down to O of n, that is to say proportional to the size of the input time. So that's, anyway, it might be O of n squared, but I don't know. It's a small. Anyway, the n is small, so it's not the end of the world. Anyway, I guess what I'm saying is, do this. Memoize things, and if you're stuck on 2019, I think that's day 22. No, I don't know. There's some problem from last year that 21 was an int code problem. Couldn't have been 21. I don't know. What's my code for day 9? I don't know. Anyway. Yeah, day 20. It had to do with 18. Okay, I'd get there eventually. 18 part 2. Here we go. I have this function memoized right there. If you're stuck on that and you're having algorithmic complexity problems on day 18 of last year. Algorithmic complexity, big O, if you're not familiar with all of these terms, they all mean the same thing. Need code, please. Which day? Here, I'll type it in the chat. Which day? Well, anyway, I lost my train. Right. So algorithmic complexity and big O refer to this idea of coming up with some way of expressing how long something is going to take, proportional to an input size, or proportional to the square of an input size, or proportional to the cube of an input size, or something. And the larger, something that runs in n cubed for an input size of 1, no problem, it runs once, right? Something that runs in n cubed for an input of 100,000, well, now you have a bigger problem. And so that algorithmic complexity is the term of art for how we describe that. And so if you run into algorithmic complexity problems, my top tip for you this evening is that memoization is maybe your way out there. And so I've posted the link to the code for last night for 10b part 2 of last night in the video for last night anyway. And I've already pushed tonight's code to GitHub, and I'll post that into the description of tonight. And if anybody has any questions, then I'll take them. Otherwise, I will see you all right on time tomorrow night.